Alright, so for video 3 we're going to set up and solve a quadratic area model. So the story that we have is that we have a rectangle that is 77 square yards and its length is 3 yards more than twice its width, and we're asked to find the dimensions of the rectangle. So the first thing that I think you ought to do in this type of a problem is catalog the information that you have and draw a good picture that models the problem. So first, we're told that the area of the rectangle we're interested in is 77 square yards. And area of a rectangle, we know that to calculate area of a rectangle, we need to multiply the length times the width of the rectangle. Next, draw a picture of the rectangle. I think it's a good idea to draw a picture of the thing that you're modeling. And length you usually label on the longer of the two sides. You don't have to, but it's pretty common. So length and width, and then we're told something about the length. It says here that the length is, here's my is what? Is 3 yards more, and that should say than, not that. Who spelled that? 3 yards more than, that means add 3 to something. And to what are we adding the 3? We're adding the 3 to twice the width. So here's the width, and the length is 3 more than twice that width. So this has effectively extracted all of the information that the paragraph has given to us. Next step, you take your area model, length times width, which is currently a function of two variables, the length variable and the width variable. And what we want to do is use this information right here to reduce our area function to a function of a single variable. So I'm going to take my area model. I'm going to replace length with twice width plus 3. So I'm going to go parentheses, and the length here gets replaced with the statement twice the width plus 3, which is still being multiplied by the width. And you don't always have to do that, but in this particular instance, I'm going to go ahead and distribute the w into the parentheses. So I'm going to get twice width squared plus 3 times the width. And this is our area model now only as a function of width. Next step is we're told that the area is 77 square yards. So I'm going to replace area with 77 square yards. And now I recognize from earlier in the term that I have a quadratic equation in a single variable. So we can use any of the tools that we have in our toolbox for solving this type of equation. We can complete the square. We can attempt to factor it and use the zero product property. We can use the quadratic equation. If we want to use the quadratic equation, then we need to get this equal to 0. And I'm going to go ahead and do the quadratic equation this time. So I'm going to subtract the 77 off both sides. That's going to give me 0 equals twice the width squared plus 3 times the width minus a 77. And then for the quadratic equation, we're going to need to know what a is. A is going to be the leading coefficient, the 2. B is going to be the coefficient on the linear term, and C is our constant, which is negative 77. So we take that information and we load it into the quadratic equation, and usually we go x equals, but we want to recognize that our input variable isn't x, it is a w. So we're going to go, instead of x, we're going to say, hey, w equals, what does it equal? It equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And this negative b minus the square root of stuff is probably going to generate a negative number, and we want to recognize, because we're asking for a width or a length, that we only can use positive numbers, so we need to keep that in mind as we crunch along here. So we're going to get width equals the opposite of b. but b was a 3, so it's going to be the opposite of 3, plus or minus the square root of b squared. So that's going to be 3 squared minus 4 times a. A was equal to a 2 down here, times c, and c was a negative 77. And put the square root symbol over all of that, and this is all over 2 times a, and a is equal to 2. Negative 3 plus or minus all over the square root of, when we simplify the numbers underneath the square root, we wind up with a 625, doing the 3 squared minus 4 times 2 times negative 77. This is going to give us 625 if you crunch it out in your calculator. And 2 times 2 is 4. And here's where you know this problem was really contrived, because the square root of 625 comes out nicely to 25. And this is all over 4. And if we simplify this piece, we wind up getting two answers out of it. We wind up getting width is either equal to, what did I get on that? I got a 5.5. And then the other number that I got I didn't need, because I got negative 3 minus 25 was negative 28 over 4, which gave me a negative 7. But we know that we can't have a negative width. So I threw the negative number away, and I just keep the positive number. The negative 3 plus 25 is 22 over 4. 22 over 4 simplifies to 5.5. So I have my width as 5.5 feet. And then we need to grab this relationship right here that says the length is 2 times the width plus 3, but we know the width is 5.5. 2 times that's going to be 11, plus 3 is 14, so we get that the length is 14 feet. And then usually you respond to a story problem in a complete sentence, so you would say something like, the length is 14 feet and the width is 5 feet. And that's a wrap on that one.